We're given the time to the first failure of an industrial robot given by this density function. And notice it's only between 0 and 10. After 10, it's undetermined. So we could just say it's 0. Consider a supplement warranty. So it pays $100,000 at time t if the first failure is between 2 and 10. And there's no benefits payable otherwise. We're given delta is 5%, and we want to calculate 90th percentile of the present value of the benefits under this warranty. The first thing we're going to do is look at the present value of the random variable. So we're going to denote that by z. So it's going to be 100,000 times v to the t if t is between 2 and 10, and 0 otherwise. So the 100,000 represents the benefit amount, or the warranty rather, and v of t is a discounting back t years. So we can replace the v of t as e to negative 0.05t. Okay. Now we can graph this. So we know it's going to be between 2 and 10, really. Everywhere else it's going to be 0. Okay. And between 2 and 10, it's going to be 100,000 e to negative 0.05t. So that's what we're graphing here. So let's say this is z of 0.9. So let's say that represents this point. We'll label the x value as h. That means that anything above it is the probability that z is greater than z of 0.9. And that's just going to be 0.1. So we want to calculate the 90th percentile. So think of this as the CDF, not the survival. So probability z of greater than z of 0.9. Think of that like is a survival. It's the complement of the CDF. So if we were to actually find the CDF, it'd be the probability z is less than z of 0.9, which is going to be 0.9. And because less than 2 and right of 10, it's 0, the region that we're interested in is this right here. So it's really between h and 10. That's where z is less than 0, z of 0.9. Okay. So now let's do some work. So we know that the probability of z is less than z of 0.9 is 0.9. That means if we were to do the complement of that, we know that z is great. The probability z is greater than z of 0.9 is 0.1. And so that means that t has to be between 2 and h. Right? That's this right here that we were looking at. This is the region that is 0.1. Okay, so we can represent this as an integral from 2 to h of f of t dt. F of t was given in the beginning. From 2 to 10, it's 0.4 times t to the negative 2. So we're going to replace that. And again, we want this to equal 0.1. So we're going to integrate this, use the fundamental theorem of calculus, and we're going to get that h is 4. So all we have to do, well, in this problem, we want to find the present value, right? So if you go back up, we want to calculate the 90th percentile. So we found the 90th percentile is when h is 4. Now we want to find the present value. So the present value we denoted by z. That's 100,000 times e to negative 0.05 to the t. So we're going to replace t with 4, and that's going to be my present value. And if we simplify that, we get 81,873.